Okay, so now let's look at this one. This is question 3 from the 2024 November paper 1. This is vertical projectile motion, one of the most easiest question, of course, if you understand the statement, right? So look at what is going on here. They said that we have uh, a ball that is thrown vertically upwards at the 12 meters per second velocity from the top of the building. 2 seconds. Okay, let me first focus on ball A. Now. So I'm going to have my building up here. Let me quickly draw my building. So this is my building. And from this building, we're going to have ball A that will be thrown vertical upwards. You know that if something goes up, it's going to reach maximum height, then it will continue going down until it hits the ground. Okay, so this will be my ground, right? So, and then the V initial at A is given as what? So I'm going to indicate that V initial at A. So I'm given the V initial to be equals to 12 meters per second. Okay, so now 2 seconds after ball A was thrown up, ball B is thrown vertically downwards. So at this point here, the very same, they say from the top of the same building. So from this point, we're going to have B, which is thrown downwards. So A moves up, B goes down after 2 seconds. Okay, so this is B, and the V initial of B is given as what? 5.4 meters per second. Okay, so now I think there's something that I need to fix here. Direction. Né? So they say that let's say I choose up to be positive. Okay, so if I choose up to be positive, you can see that the velocity of B will go down, which gives us negative that 5.4 meters per second. Okay, we'll keep on going back to if we need something. Okay, both balls A and B strike the ground at time 2 seconds. Guys, look at this. I need you to understand what is going on here because this is very important. We throw ball A up, and then after 2 seconds, with ball B is thrown down, but they both reach the ground at the same time. So this tells you that the time that ball B for ball B, so the time that ball B was projected up, the time for ball P is going to be what? We're going to take the 2, which is the time that the ball reached the ground. We minus that 2 seconds because it was, this will be my delta T for ball B because it was projected 2 seconds after. Because if you understand that part, all good. So I'm going to say this again. Ball A is projected up at 12 meters per second. So 2 seconds after, ball B is projected down, but both of them, they reach the ground at time t. So to find the time that ball B was projected, we take the t, which is the time that they're going to reach the ground, with we subtract 2. Ignore the effect of air friction. The position time sketch graph for both of the balls are shown below. Okay, so let me explain what is going on here. Let me start with ball A. So ball A, it starts at Z, which is the height of the building. Then it is projected up. So this is your Z. Okay, that point there, that's your Z. Then it is projected up to the maximum height. So this is point Y. The maximum height is at Y. Then it goes down all to hit the ground, which is point T. That's your T. Okay. So then for ball B, I think you can just see that ball B starts here, then it travels down. Okay, let's see what we have on the question. They say using the equation of motions only. Use the equation of motions only. They want you to calculate the value of each of the following. Number 1, T. You need to ask yourself, this is 5 marks. We can't donate those marks. Now, I really Don't like when you guys donate marks because of those silly mistakes that you make now. So using the equation of motions, calculate the value of each of the following shown in the graphs. The equation of motions, and we need to find t. What is t? T is going to be the time that uh, both of these balls hit the graphs. And how are you going to approach this question? First thing first, you need to remember to select direction. So I'm going to say up as positive. So up will be positive, then I'm going to do my data. Right, so if I take up as positive, I'm forced to take all, when I work on these other three questions, I should also work with up as positive, okay? Right, let's choose up as positive, and we're going to calculate the value of t. So to calculate t, we need to know how long it took ball A to reach the ground. Guys, remember, the time for ball B, it will just be t minus 2. So in order for you to know, to calculate the time it hits the ground, we need to understand how long it took ball A to reach the ground. So first thing first, let me consider the motion of ball A. Let me start with ball A. Okay, you'll go to your formula sheet, but you're going to do this. You're going to do what we call data for ball A. Then on data, you're going to write what you are given for ball A. So we set up as positive, and the V initial for A is 12. So this will be 12 meters per second, which is positive. I think it's best if I just put my data here so that I can do the substitution on the other side. So what we are saying is that for ball A, I'm going to write everything that I have from the statement from ball A. So I'm going to take, okay, sorry about that. So this is ball A, and I'm going to say V initial is 12 meters per second. And then what else do we know from ball A? We know that ball A will have the acceleration which acts down. It's 9.8, but it's negative because the acceleration always goes down, meters per second. And what else do we know from the statement? Nothing else. Nah? This is what we know about ball A. Right. Then I'm going to use the equation of motions to do my substitution, okay? I'm going to use the equation of motion. So you'll go to, we are trying to find what? We are trying to find the, in order for you to understand, we need to find the time it took to reach down the ground, okay? So I'm going to use the formula that has delta y, right? Even though I don't know what is delta y, I'll explain why I'm going to choose that formula. So you'll go to your formula sheet, you find delta y, which is equals to v initial delta t plus 1 over 2 a delta t squared. So now someone will ask, why are we choosing this formula? Guys, look at this. We don't have the final velocity because I can't use the v final there at 0. I can't use that one. So I don't have the final velocity. I'm not going to choose, unless if I have the final velocity that it hits the ground with, then I can choose the formula that has the final velocity. So most of the formulas that they have the final velocity, I'm not going to choose that one. This is the formula I'll go with. Then when you do your substitution, delta y will be v initial, which is 12, delta t. So what is delta t? They said that both of the ground will strike at time t. So the time it will take ball A to reach the ground is t. So where there's delta t, I'll substitute t. This is plus 1 over 2 into negative 9.8. Then this is multiplied by delta t, that's t squared. I'm going to call this equation 1. Right. So if this is equation 1, then I'm going to do the same for ball B. I need the data for ball B. Right. So for ball B, we know that the V initial of ball B look at this. Ball B, it's going down with 5 point, but we said it's going to be negative. So it's going to be negative 5.4 meters per second. And then ball B will have an acceleration of negative 9.8. Then you're going to substitute everything that you have there, put it on that formula to create equation 2. So delta y is equals to, where there's v initial, I'm going to put minus 5.4, which is multiplied by t. Then we add, what is this? Half of negative 9.8. Right. But now we are making a very big mistake. Remember, what is the time for ball B? We said that the time for ball B will be t minus 2. Okay. We need to first multiply the 2 seconds that ball A traveled up before ball B was projected. So this will be delta y is equal to minus 5.4 inside the bracket. Delta t for that one is t minus 2. Then I'm going to add half of negative 9.8. This is multiplied by that, which is t minus 2. And this is squared. You see? So we have two equations now. Both of these equations, if you solve for t, the t that you get is the time that it will take both of these balls to hit the ground. As you can see, guys, we don't have much space, but I'm just going to try and take the two equations and equate them this side, then I'll try to work on them. So this is my equation 2. So I'm going to take equation 1 and equation 2 and try to solve them down here. So equation 1, because it's delta y and delta y. So delta y is equal to delta y. I'm not sure if you guys understand, but let me explain how this works. Both of them are equated from the same height. So I'm going to say delta y is equal to delta y. So I can equate the two equations and say this will be 12 t. Then look at this, half of 9.8. What is half of 9.8? If you punch that on the calculator, so it's like saying, I think we're going to use the calculator this time. It's like saying half of negative 9.8 is 4 point something. Negative 9.8. That's 4 point something. And this gives us negative 4.9. So this will be negative 4.9. So this is minus 4.9. Then the minus 4.9 is multiplied by what? It's multiplied by t squared. So this will be t squared. Then we're going to equate this to the second equation. Then let's multiply out the bracket here by that minus 5.4. So it's going to be minus 5.4t. Then we multiply the bracket by the minus 2 by that minus 5.4. So negative and a negative gives us positive. Then you're going to say 5.4 times 2 and see what you get. 5.4 multiplied by 2, this is equals to 10.8. So this will be plus 10.8. Then now I'm going to work on this too, guys. I know that this will give me, look at this, half of negative 9.8, that's negative 4.9. We said it's 4.9 into t minus 2 squared. So I'm going to write this as minus 4.9, then expand the bracket, t minus 2. Then first thing first, before I multiply out the bracket by the 4.9, I need to use the FOIL method to know what is that. So this is 2 squared minus 4t plus 4. So I need you to verify that using what? I need you to verify that using your, you can just pause the lesson and use your FOIL method. First multiply the bracket with t, then multiply the other bracket with minus 2, then add the like terms. So what's next? We need to multiply out the bracket with that minus 4.9. Because whatever that I get, I need to substitute it right there. Okay? So I'm trying to simplify this part here. That's what I'm trying to do. So when I multiply out the bracket, I get this as minus 4.9 t squared, then minus 4.9 times 4. So this will be minus negative 4.9. We are multiplying out the bracket with negative 4.9. Negative 4.9, it's multiplied by negative 4. And this gives us 19.6. So this will be positive 19.6 t. Then we're going to say we already know that 4.9 times 4, that's 19.6. This will be negative 19.6. When you say minus 4.9 times positive 4.9, it will give us minus 19.6. So now that this is factorized, this is simplified. What I'm going to do, I'm just going to put it down somewhere there. I'm going to put it down and say this is minus 4.9 t squared. I am very sorry, guys, about the space. Then, or maybe should I write this? Then I'm going to add, let me just put this one on top here. We're going to add 19 point, we are adding 19.6 t, then we subtract 19.6. So I'm going to group the like terms. So I don't want to waste time on this one now. So look at what I'm going to do. I have minus 4 t squared, and this side I have minus 4 t squared. So you can see that if this one goes this side, it will be positive. So those two will cancel. So those two are out. This side I'm only left with what? 12t, and this is equals to, I need to add the like terms this side. I need to add the minus 5.4t with the, I need to add that with that, what is this? The 19.6t. I need to add the two. Let me see what I get when I add this. This is going to be, we added the minus 5.4 minus 5.4, we need to add that with 19.6t, 19.6. And this gives us an answer of 14.2t. So this will be positive 14.2t. Then I need to add the positive 8. Let me just indicate that with a different marker. So this will be the positive 8. I have to add that with what? With the negative 19.6, because those are the like terms, right? So it's going to be positive 10.8. Then I subtract that 19.6. And this gives us negative 8.8. So this will be negative 8.8. Okay, so let's take the 14 to the other side. This will be 12t minus 14.2t. It's equal to negative 8.8. Therefore, I'm going to say 12t minus 14.2. 12 minus 14.2. What is that equal to? This gives us negative 2.2 t. Negative 2.2 t is equals to negative 8.8. Therefore, divide both sides by negative 2.2. Divide both sides by negative 2.2. Guys, I'm going to go all this trouble because I need the 5 mark. Unless if you have another method that you can use. Maybe another easy method that you can use is fine. You can just go with that method now. So when you cancel this side, t is equal to negative 8.8. We need to divide that. This is negative 8.8. We need to divide the negative 8.8 with the answer. Okay. We take negative 8.8 to divide that by answer. This gives us 4. Therefore, t is 4 seconds. That's your answer. So this tells you that the two graphs took, the two balls, they took 4 seconds to reach the graph. I hope you are happy with that. I hope you guys understand. please just try to make sure that you pause the lesson, equate these two questions, equate them, and try to solve this on your own. Number 3.1.2, they say we need to calculate Z. You need to ask yourself, what is Z? Look at this. This is the position in meter. So it's the height of the building where the ball A was projected. So that's the height of the building. Right. If we are looking for the height of the building, I know the formula that I need to use because I'm looking for delta y. I can use, let's say, I'm going to look at, let's say I consider ball A. I'm going to look at ball A, or you can also look at ball B. You can also look at ball B, okay? So it's up to you what you want to look at. So let me just look at ball B now, because even if I look ball A, we're still going to get the answer. But look at this. It's easy for me to find the height from that point to that point. If I look at ball A, I know that the V initial at ball A was minus 5.4. So I'm going to say that for ball B, not ball A, ball B, delta Y is equals to V initial. This was V initial delta T plus half A delta T squared. So I'm going to do the substitution. My delta Y will be the V initial of ball A. We set it's minus 5.4. The time, guys, we set the time for ball B. It's T minus 2. And now we know that T is 4. We minus 2, then this would give us 2 seconds. So I need to sub in there time as 2 seconds for ball B. So it took 2 seconds, ball B 2 seconds to reach the ground. So this will be 2 plus the half of the acceleration is negative 9.8. Therefore, delta T, this will be 2 to the power 2. Therefore, you just have to punch that on the calculator and see what you get. And another thing that you need to note is that ball A is traveling down, which means that the displacement of ball A will be negative as we set up as positive. So everything that goes down, the displacement of that thing will be negative. So when I punch this on the calculator, I expect to get a negative answer. And if I don't get a negative answer, then I'm gonna check and see, because this will mean that somewhere, somehow, my substitution is incorrect. Okay, then this is, we are adding, okay, half of negative 9.8. Okay, negative 9.8, then this is multiplied by 2. I'm not sure, guys, if this will give me the answer, but it looks like it's going to give me an error because of the graph. Let me check. Okay, this gives us negative 30. You see, the answer, my answer is negative. So this tells me that the displacement of ball A is going down. So that's negative 30.4. So that's the answer. So this will be negative 30.4 meter. So since it's negative 30.4 meter, we can conclude and say Z is equal to 30.4 meter. The negative is just telling you where is this object moving. You understand? Yeah. So that's it for this one. Let's look at 3.1.3. 3.1.3, they say that we are looking for Y. Oh, okay. I think this will be easy. Look at this Y here. Y is there, if you look at the graph there, Y is the maximum height that ball A reached. And it's going to be easy for you to find the maximum height that the ball A reached. I can even consider the maximum displacement of the ball A, which is above the point of projection. I'm not sure if this makes sense. Let's consider the maximum point. The maximum point. Let's say the maximum displacement of ball A above what? Above the reference point. So I can say that I know that if point A started at this building, then it travel up, then it reach maximum, it comes back to this same point, then it continue moving down. So what I need you to understand is that the distance that it traveled going up is the same. You see, we can find the distance that it went up, and then we can add that with that distance, which is something that we already know, that the height of the building is 30.4. So if we can find the distance that it traveled to its maximum height, we'll know what is y. So we'll know what is y. I'm not sure if that makes sense, but let's work on that. So I'm going to use, because now I know that the V initial of A is 0 because it reached the maximum height, and then the V initial is 12. So I can use the formula that has the V final, the initial, the final velocity. And the formula goes like this. So this is 3.1.3. So the formula will go like this. And I think it's best if we just take this question up there so that we can have space to answer 3.2. Okay, so we are saying that the formula is Vf squared. It's equal to V initial squared plus 2A delta y. We are looking for delta y, right? And the initial velocity at the final is 0. And then V initial is going to be 12, and this is squared plus 2 into the acceleration. So remember, the acceleration is going up. This is negative 9.8, then delta y. And then now I'm going to say the 12 squared. What is 12 squared on your calculator? I think it's 144. But let me confirm. 144. So if I have 0 is equal to 144, then I'm going to say negative 19.6 delta y, because if I say 19.2, it's okay, 9.8 times 2, that's 19.6, but it's negative, right? Then this will be negative 144 to the other side, negative 19.6. I'm going to isolate the term that has y, so that I can divide both sides by that negative 9.6, divide both sides by that negative 9.6. The answer that I get is my delta y. You see? So I just have to take the question and say 144 divide by, I know that the negative will cancel, so I'll just say 144 divided by 19.6. What is my delta y? My delta y is 7.35. Guys, I'm very sorry about the calculator, but just write the number that you see there, which is 7.35 if we round it off to 2 decimal places. 7.35. So this is the maximum height, 7.35 meter. So this is the maximum height. And if that's the maximum height, what will be the height? What will be the height at y? We need to add the 2. So we know that from this point here to that point, the distance between those 2 points, this one is 7.35, and the distance between that to the ground we said is 30.4, right, meter. So we just have to add the 2. So this tells you that at y, the distance will be 30.4. You added that with 7.35. 30.4. I'm going to take this at 30.4. 37. So the answer is 37.75 meter. And that's it. Easy enough. Okay, last question. They say that on the same set of axes, sketch the velocity time graph. The velocity time graph. So if they want the velocity time graph, I need to say this will be my graph like this. This is my graph, and then this will be my velocity. and this will be my time. I'm just gonna try and put everything that I know so far on this graph, and then I'll explain how this goes. So first thing first, the reference point, guys, it's 0. So when I say the reference point, where the graph start, not exactly where the graph started, uh, I'm going to call the maximum height when the velocity is at maximum height. That's when the velocity is 0. I'm not sure if you guys understand what I'm saying. Look at this. V initial is equal to 0. It's at maximum height. So this tells you that if I say the velocity there is 0, this is your maximum height. Let me focus on ball A. Ball A, it starts with the velocity of 12. So if I say this is 5, 10, 15, we know that 12 will be somewhere there. So for ball A, it will start where? It will start at 12 with the velocity of 12, right? And then it moves up. Look at this. What happens when it moves up? It decreases in velocity. Okay, and we set up as positive. So when the velocity is moving up, it will be above that 0, but it will go down. Why? Because the velocity decreased all the way to the maximum height. So at this point, that's your max height. But I'm going to label everything when I'm done with my drawing. Okay, so then when it reached the maximum height, the ball A starts going down, meaning that now it has a negative velocity. Why? We set up as positive. So it will start having what? A negative velocity. It will go down with a negative velocity. The more it goes down, the more it hits the ground with a negative velocity. So this tells you that it will hit the ground at time. Let's say I decide to put my 4 there. So this will be at T4. This will be my T4. That's when it's going to hit the ground. I hope you guys understand. And this will be for ball A. This is the graph of ball A. Right. So one thing that I realized is that when I look at this, um, both balls are in free fall. So since both of them they are in free fall, the entire motion. So they are in free fall the entire motion, right? Therefore, this tells you that there will be parallel lines with the gradient. Né? So now to draw for the ball B, where is ball B starting? You look at the velocity that ball B was projected. This is the point where ball B was projected, and it was projected with the velocity of negative 5.4 because we set up as positive and that velocity is going down. So if I put minus, let's say I put minus 5.4 there. So velocity, the ball B is going to start at that point. Okay, so it's going to start at that point, and when I look at the time, it's going to be projected. We set t minus 2. 2 seconds after ball A was projected. 2 seconds after. So I'm going to put maybe 2 there and say it was projected 2 seconds after. Let's say from this point, 2 seconds after. Okay. 2 seconds after ball A was projected. So maybe I can say this is 2. Then it was projected somewhere at this point. Then when it goes, it's moving down. You see, it hits the ground at T4. So it's going to move down and hit the ground at that T4. So it's going to move and hit the ground at T4. So this will be my ball B. Simple. Then this is your graph. If you give them this graph, you'll definitely collect all the marks. But let me help you understand what is going on at the graph. Now, you see this point here. This point here, this is the point where ball A is projected upward. So ball A, we're going to say is projected up, right? At 12, let's say at 12 meters per second. Right. And then at this point here, at this point, ball B was thrown downwards. So at this point here, that point we say ball B was thrown downwards. And what was the velocity? At V is equals to negative 5.4 meters. And then we said at what? At T is equals to 2 after 2 seconds. Right. And then this point here and that point, these 2 points is going to be both ball reach the ground. Both of them. Both reach the ground. 100%. Okay, I think we did explain everything, right? And then now last thing is that both of these two lines, the lines, both of them, if you look at the lines now, I'm not sure where I'm going to put this one. This line there and that line there. Both of them are straight lines and they have the negative gradient. So both lines are straight line. Both of them, they are straight lines with a gradient that is equal to negative 9.8 meters per second squared. And that's it for this one, guys. I hope you really understand how to work around this question. Yes, I can say easy 16 marks, but I can say easy 12 marks. I know that you can have challenges when it comes to do the drawing, but this is what you need to do when you do the drawing. The most important thing is to say, oh, it starts at 12, it moves up. So since it moved up, it decreased in velocity until it reached the max height. So this is at max. Then from there, it start moving down. We set it down as positive, as negative, up as positive, down will be negative. So once it at maximum, it start moving where? It start moving down with a negative velocity until it reach the ground at T4. So let's say that in an exam, they said, calculate the velocity that it will hit the ground. Whatever velocity that you get, you should make sure that it goes same as that point. And that's it for this one. I'm looking forward to work with you guys on the next question. Remember, if this is your first time on the channel, we still have massive questions to work on. Make sure that you join the family. Just subscribe to the channel and we'll make sure that you feel at home.